So these three we know. We've talked about these already. We said oscillation is a repeating to and fro motion, back and forth, up and down, forwards and backwards, whatever you want to say. Amplitude is maximum displacement from equilibrium. Period is the time it takes to make one oscillation. So one oscillation is called a period. The time for that is called the period. I should say the time. All right. Let's look at these next two. I'm going to do these two with you. And then we'll talk about the next couple after that. All right. Waves. So a wave is transport of energy through a medium. You might be saying to yourself, Self, what's a medium? It is the material through which a wave travels. Or a wave travels through. Okay. You'll probably want to book for these. I want you guys now to do F through I. So I did waves and medium. You'll probably want to book for them. They're in the back. But I want you guys to do F through I. Well, look out for me. What's a crest? Jordan, what you got for that one? Good. So maximum displacement, I'm going to say the maximum distance from equilibrium, so the positive maximum distance from equilibrium, but it's basically the top part of a wave. So positive amplitude for a wave. And again, that's max distance from equilibrium. All right, Eli, what about a trough? What's a trough?
The lowest part of the wave.
Yes, the lowest. So it's the negative amplitude. Here's how you remember them. When waves get to their highest, largest point and start falling down, it's called cresting. So it's the top part. And animals eat out of food troughs, which is like an upside-down U-looking thing. Okay? So animals, not that you guys have extensive knowledge of animals and feeding them, but I grew up on a farm, so that's how I remember it. Okay? Wavelength. Lucy, what you got for wavelength? Yeah, it's the length of one wave, which is usually measured from crest to crest or from trough to trough. So it's the length of one wave, which is, again, usually measured from crest to crest or trough to trough. Good. Jonah, what about frequency? What's frequency?
I said it was the number of vibrations per a given amount of a given time, I guess.
Yes. So frequency is number of waves, and we're going to use a very specific amount of time, number of waves per second. And the unit for that is hertz. So the unit is hertz, and the symbol for hertz is Hz. All right, almost done here. Let's knock them out. Last two. Transverse wave and a longitudinal wave. So a transverse wave is where the wave travels forward and the particles travel perpendicular. And a longitudinal wave is where the wave travels forward and the medium particles travel parallel. That makes no sense. Just write it down. I'm going to show you what each of them looks like. Then it'll make sense. So wave travels forward. And the medium's particles move perpendicular. And a longitudinal wave is the wave travels forward. And the medium's particles move parallel. I need a volunteer, but you don't get to know what you're doing. Don't get so excited. No? You get to play with the slinky. Still no one? Oh man, you guys are all lame. Here goes Zach. Hop down here on the floor for me. All right. If you're in the back, come up so you can see. If you're in the first two rows, you can probably see fine. But if you're in the third or fourth row, come on down so you can actually see. Have a hop on the floor. Pop a squat. Oh my gosh. At 35, your joints don't bend like they do. This is a slinky. It is a, I know. It is the medium. Medium is what a wave travels through. The wave is going to go through my slinky. A transverse wave travels forward, Zach, while the particles move side to side. So how do I make a transverse wave? I move the particles side to side. Ta-da! Transverse wave. You're like, oh, I've seen these before. Yeah, these are what you think of as waves. When you see a wave and you're like, oh, that's a wave, you're thinking about this. This way you're thinking about it. Okay? All right. Longitudinal waves, those waves move forwards and backwards, and the particles move in the same direction. So if I want to send it to Zach, I would push it in the same direction. That's a longitudinal wave. Okay? That's a longitudinal wave. So longitudinal waves move in the same direction as the particles. Transverse waves move 90 degrees to each other. So particles go side to side, wave goes forward. The other ones move in the 0 degrees, same direction. Particles go forward, wave goes forward. Okay? Questions on what those two things are? Okay, you can have a seat. All right. That's enough notes for today, I think. Mark, you were just getting started, weren't you? You just wanted to go all the way through the notes. That's right, they're going to play slinkies without you. All right, let's talk about the labs. So notes, keep those handy because you'll need the definitions on the labs, and if you get confused, you can look them up. Okay? Take a look at the two lab sheets for me. Lab A? Lab B. Let's start with Lab A. You are going to draw a wave. It's going to look like this. So, how do I actually draw the wave? You're going to need a blank sheet of paper. You're going to get it from up here. I got a bunch of butcher paper. Cut you off a slice, about that size. Okay, so work with your partner, the person sitting next to you. Transverse wave can be modeled when a marker moves back and forth vertically over a piece of paper that's being pulled across the table or the floor. If done carefully, you should see a nice, consistent sine curve on your paper. A sine curve is just a fancy word for a wave. So, what I'm going to do is I'm going to pull the wave forward, pull the paper forward. As I pull the paper forward, I'm just going to go side to side with my paper. So it's going to look something like this. Oh my gosh, terrible, 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 terrible. Yours is going to look much better because you're not going to be doing it yourself. You're going to have your partner moving it. But that's what it's going to look like. Okay? Yours is going to look much, much, much better than mine. But that's the idea of what you're doing. So your partner is going to pull the paper while you move the marker side to side, or vice versa, obviously. Okay? Place a large sheet of paper on the table or the floor. One group member should steadily pull the paper across the table while the other member moves the marker back and forth over the paper, perpendicular to the motion of the paper. The arm should swing freely like a pendulum. One group member should use a stopwatch to measure the amount of time needed to sketch the motion over the length of the paper. So you should go the whole length of the paper, and someone should time it. Generally, the person moving their arm is the easiest person to time. So that person needs to time what's going on with it. Okay? All right. Record and calculate the values on your wave diagram, not on this sheet. Show all your work. The parentheses show how you should label it on the paper. So, for example, it says record the total time t of the wave of motion. So you would write on your paper t and write down how long it took. Then on your paper next to that, you would write total number of wavelengths. You would write number of lambdas. That's a funky upside down y is the Greek letter lambda. So you write number of upside down y's. And then you would put how many you have. So a wavelength is one full motion of a wave. So how many full motions of a wave do you have? You would count them on your paper and you'd write that number down. It's okay to go to a half a wave. So it's okay to have 3.5 waves instead of 4 or instead of 3. And you just keep going from there. Find the period. Remember, period is the time it takes to make one wave. So see if you can figure out how long it takes to make one wave. Frequency, remember, is how many waves happen per second. So based off of your numbers, how do you figure out how many waves per second? And that's how you go through the thing. Notice that you're going to write it on the paper itself. Write all those things on the paper. When you get to the end of that one, you'll switch over to the other side. And I'll stop recording.